The year 2024 went down in history as the hottest year on record. Absolute temperature records were set all over the world. Residents of Australia had to deal with temperatures reaching 50.7 degrees Celsius. In Canada, the hottest recorded temperature was 49.6 degrees Celsius. And in Mexico, on the hottest day, the thermometer climbed to 52 degrees. Just think about it, 52 degrees Celsius. That no longer feels like weather, but more like a free simulator for surviving in extreme climates. At the same time, abnormal heat is drying out the heart of South America. The Great Amazon, the most water-rich river on the planet and a symbol of endless greenery and moisture, is beginning to grow shallow and gradually dry up. And on the other side of the planet, the glacier that earned the dramatic and well-deserved name, the Doomsday Glacier, continues to collapse rapidly. Every year it loses about 50 billion tons of ice, enough to fill 20 million Olympic swimming pools. If this giant, only slightly smaller than the state of Tennessee, melts completely, the global sea level will rise by nearly 10 feet. That would cause serious problems for many coastal countries. Lately, our planet seems to have had a fever. Record heat, drying rivers, melting glaciers. All of this we're already witnessing with our own eyes. But what's truly frightening is the possibility that all this might not even be the worst that awaits us. And now we want to ask you a question. What do you think would be harder to endure? Unbearable heat or freezing cold? Scientists believe that in the coming decades, part of the planet may fall into a new mini ice age, while another part could sink underwater. And this is not tabloid clickbait, but real conclusions from researchers all over the world. The reason lies in the processes happening right now in our ocean. Take a look at this map. Here, near Greenland, there's a strange spot. It's a massive area of water that stubbornly cooled over time, despite the rest of the world heating up. Scientists believe that this cold spot is connected to the weakening of a vast system of ocean currents that for millennia worked like a thermal conveyor belt. It transferred heat from south to north, heated Europe, regulated monsoons in Africa, and even influenced hurricanes in the Americas. This system can be called the planet's main climate engine, and now this engine is starting to malfunction. The consequences could be far worse than heat. Europe risks plunging into a new ice age, while part of America could go underwater. And the most frightening part is the timeline. According to the latest studies, the beginning of the catastrophe may come much sooner than expected. Global warming or an ice age? The world will never be the same again. You may have heard it many times, but when it comes from experts at the World Meteorological Organization, it sounds especially alarming. Take a look at this chart. It shows how the average temperature of our planet has changed over time. And most importantly, since the beginning of the Industrial Revolution until today, it's risen by 1.5 degrees Celsius and now stands at about 17 degrees Celsius. Your first thought might be that it sounds like nothing special. 17 degrees Celsius seems like a cool evening. But it's important to remember that this is not the air temperature in a single city, it's the average temperature of the entire planet. And an increase of 1.5 degrees Celsius is already a huge jump. Imagine if your body temperature suddenly rose to 38 degrees Celsius. You could endure it, but your body would already be struggling and working under stress. Something similar is happening with the Earth's climate. Glaciers are melting, ocean currents are shifting their rhythm, droughts and abnormal rains are becoming more frequent. A small number on the chart turns into global consequences that we're already beginning to feel. And the causes of all this is the greenhouse effect, the very phenomenon we've been hearing about from all directions in recent years. It's the extraction and processing of oil, the construction of factories and plants that have led to the release of huge amounts of gases that trap heat on the planet. The clearest example of a catastrophic greenhouse effect in our solar system is Venus. Its incredibly dense atmosphere is filled with carbon dioxide and sulfuric acid, preventing heat from escaping the planet. In other words, the sun heats the surface, but the heat barely escapes back into space. The planet simply cannot cool down. If Earth's average temperature has recently reached a record 17 degrees Celsius, on Venus it reaches 470 degrees Celsius, a true greenhouse from hell. But Earth's fate is unlikely to follow the Venusian scenario anytime soon. Things may unfold in a completely different way, with entirely different consequences. This footage was filmed in September last year. Snowfall came suddenly, catching people on the highway and halting traffic within just a few hours. Many even had to spend the night in their cars. You might say that's nothing out of the ordinary, and we'd agree, except this footage was taken in South Africa. Sometimes, though rarely, air currents from Antarctica reach this far north, and when they do, real anomalies occur. In some areas of South Africa, up to 6.5 feet of snow fell within just a few days. That's not what we'd usually expect from these latitudes. But this scene is an illustration of what may await almost all Europe in future. Not as a temporary episode, but as a real threat lasting thousands of years. And the reason for it may be what is happening right now in the depths of our oceans. All oceans on Earth are connected in a single network of underwater currents. A kind of circulatory system of the planet that can change the climate beyond recognition. These currents carry nutrients, carbon dioxide, oxygen, and, most importantly, heat across the globe. Warm surface waters heated near the equator flow north and south, warming continents along their path. Reaching the polar regions, they cool, become denser, and sink into the ocean depths, where they return as cold currents, completing this giant climatic conveyor belt. Here's one of the most important oceanic currents of its kind on our planet. It carries heat from the tropics to the poles and literally heats almost all of Europe, the famous Gulf Stream. The very reason why you need an umbrella in England more than sunglasses is only part of this enormous system. It's called the Atlantic Meridional Overturning Circulation. For the past 10,000 years, this circulation system has given Europe its signature mild climate. But it looks like this may stop in the near future. When scientists began creating a temperature map of the oceans, they encountered a curious anomaly. Over the past 120 years, the surface of the seas and the oceans has increased in temperature almost everywhere, except for one area near the coast of Greenland. Here, on the contrary, the water remains cold. Moreover, it's gradually becoming colder. This cold spot lies exactly along the route of the underwater current that's responsible for Europe's warm climate. That's a clear sign that something's happening to the current. It's starting to weaken. And, interestingly, similar events have happened before. Scientists have found that over the past 100,000 years, this current has weakened several times. Each disruption led to serious climate changes in Europe, bringing cold and ice. In just a few decades after circulation stopped, a huge part of Europe became covered by a blanket of snow and ice. The last shutdown of the Atlantic current occurred about 12,900 years ago. In North America, the giant frozen Lake Agassiz was melting and an enormous amount of fresh water poured into the ocean. This event, likely triggered by a comet impact, was followed by a sharp glaciation. You may ask, how long did it last? Not years, not even decades, but an entire 1,300 years. A true mini ice age, localized but striking nonetheless. Today we're observing the current starting to weaken again. Scientists around the world are not just concerned. A genuine atmosphere of alarm is emerging in scientific circles. On October the 21st, 2024, A letter was published in which leading climatologists called on the politicians of northern European countries to pay attention to the potentially imminent and devastating collapse of key Atlantic Ocean currents. The address was signed by 44 scientists, including Michael Mann, Presidential Distinguished Professor and Director of the Penn Center for Science. He and other experts claim that the consequences of the weakening Atlantic circulation are severely underestimated and require immediate action. In the letter, scientists urge politicians to take measures to reduce greenhouse gas emissions in their countries and to at least slow the melting of glaciers. According to them, this is the key cause of the approaching collapse of circulation. But what exactly is happening in the ocean that causes the current to weaken? The issue originates from melting glaciers. The melted water enters the ocean, and since fresh water is lighter than salt water, it stays on the surface and does not sink like denser salt water does. Simply put, melting glaciers literally disrupt the work of the currents. Fresh water does not sink and does not take part in circulation. Warm air only intensifies the effect. Surface waters don't have time to release heat and sink as they should. Researchers predict that if this circulation collapses, temperatures in some European countries could drop by 5 to 15 degrees Celsius within a matter of a few decades. And this is only the beginning. This trend would continue, and it seems we won't have to wait long. If carbon dioxide emissions remain at their current level, and it's unlikely they'll decrease, the opposite is more likely, by the end of this century the average global temperature compared to the pre-industrial period could rise by 2.7 degrees Celsius. At the same time, the first consequences of the Atlantic circulation collapse could appear as early as 2063, though some models predict this event could happen as soon as 2057. By the end of the 21st century, Europe may gradually begin to literally freeze over. With each passing decade, as the Atlantic meridional overturning circulation stops bringing heat, European countries will face increasingly harsh and cold weather. In other words, global warming in this region may be replaced by a local ice age. A planet of deadly contrasts. That is what Earth may become for future generations, as sad as it sounds. But even this will not mark the end of our climate challenges. The prolonged and intense cooling of Europe is only one of the possible consequences of the Atlantic current collapse. The United States may face an even more dangerous fate. The sinking states. This is the Prime Minister of Tuvalu, a small island nation in Polynesia. In 2021, he recorded his address for the UN Climate Conference. The close-up shot at the beginning was not accidental. As the camera pulls back, it becomes clear that he's standing knee-deep in water. The main message of his speech was direct and alarming. We are sinking. The highest point of this country is only 14.5 feet above sea level. Many areas of Tuvalu are already below sea level, 2 to 3 feet deep. That's why Tuvalu may become the first country to take the hit, and tragically go down in history as the first nation to disappear completely because of global warming. The reasons for concern are very real. A tiny territory of 70 square miles is home to about 59,000 people. For them, the prospect of flooding no longer looks like a threat, but almost like an inevitability. Even if the world begins reducing greenhouse gas emissions right now, it may already be too late to prevent the consequences. The weakening of the same Atlantic circulation that's warmed Europe for centuries will bring new problems. It's not only about long and harsh winters for Europe, but also about a rise in sea level on the east coast of the United States by 2 to 3 feet, according to experts' estimates. The reason is simple. The warm water of the tropical Atlantic and the Caribbean Sea will stop moving north along the east coast of the US to transfer its heat to Europe and return back. Without circulation, this warm water will remain off the coast of the US. And since warm water naturally expands, this will lead to a local rise in sea level in that region. Coastal areas of Miami and Florida will be at risk of flooding. Low-lying parts of Manhattan and Brooklyn, as well as coastal areas of New Jersey, will also face flooding during storms and high tides. And the number of similar extreme climate events will grow. The reason is the same: changes in the water temperature near the US coast. It will rise in temperature and, in the literal sense, creating ideal conditions for powerful storms and hurricanes to form. Warm ocean water is a source of energy. The higher its temperature, the stronger the storm, the faster the wind, and the higher the waves. In the future, hurricanes will not only become more frequent, but also far more powerful than anything we've seen in recent decades. Even the most devastating disasters of the past, like Hurricane Katrina in 2005, which destroyed New Orleans and took hundreds of lives, or Hurricane Sandy in 2012, when water flooded the streets of New York City and New Jersey, leaving millions without power, will pale in comparison to hurricanes of an entirely new scale. So, what are we dealing with? Massive hurricanes, floods, and droughts caused by rising temperatures in the eastern US, alongside freezing in Europe, all against the backdrop of a rising global sea level. It sounds like the plot of a well-funded sci-fi movie, but according to climatologists around the world, this fiction may become our reality by 2100. But don't countries care about the future approaching us, and aren't they taking action? In fact, they are, but the speed and effectiveness of these actions leave much to be desired. Still, some ideas are genuinely interesting and, strangely enough, very expensive. This is the edge of the Thwaites Glacier in Antarctica, also known as the Doomsday Glacier. We mentioned it at the beginning of the video, but we simply couldn't avoid bringing it up again. The idea proposed by scientists and engineers to stop its melting is truly unique. This Antarctic giant covers an area comparable to the state of Pennsylvania, 46,000 square miles. Its size matches the scale of the problems it carries. Nearly 80% of the icebergs floating in the southern parts of the world's oceans are fragments of Thwaites. The ice loss from this glacier currently accounts for about 4% of all global sea level rise. In other words, it's a true behemoth, a leading cause of ocean level increase. But scientists propose to fight back and have prepared a countermeasure for the glacier called geoengineering, large-scale projects with far-reaching consequences. The scientists' proposal is this: to create a series of giant, overlapping plastic or fiber curtains anchored on concrete foundations. Why, you might ask? To block the warm water current striking the glacier from below and accelerating its melting. This barrier would stretch for 50 miles along the entrance to the Amundsen Sea and rise 2,000 feet from the ocean floor. Yes, that's right. Instead of spending decades cutting greenhouse gas emissions and waiting for results, scientists suggest beginning construction of this barrier in the near future. The cost of such a project is currently estimated at an incredible $80 billion. About 8 times more expensive than one of NASA's most successful missions, the launch of the James Webb Space Telescope. Another method is used in Switzerland, where glaciers are literally covered with special blankets to reflect the sunlight and heat, slowing down the melting. It sounds strange, but it really works. Each wrapped glacier melts about 70% slower than usual. However, it must be acknowledged that building barriers for glaciers or covering them to stop melting is, to put it mildly, ineffective on a global scale. It's unlikely anyone would expect a tailwind to stop a car with failed brakes. The same applies here. Greenhouse gas emissions from global industry have reached enormous proportions, and local measures can hardly make a significant difference. In 2021, China's industry alone emitted 1.5 million tons of greenhouse gases into the atmosphere every hour. To grasp the scale, it would take about 1.5 billion cars to release the same amount in the same amount of time. Today, air pollution has become an indicator of wealth. The smoke rising from huge factory chimneys reflects a country's income level. The more emissions, the larger its industrial system, and therefore the more money and influence. The world continues to heat up, and the point of no return is drawing closer. Some experts believe that the collapse of the Atlantic meridional overturning circulation can still be stabilized, but with each passing year, the chances grow smaller. Most scientists studying Earth's ocean currents are certain if the rise in atmospheric temperature is not stopped, some regions will face cold and snow, while others will face droughts and floods. But whatever we do, the planet faces yet another climatic event, one that humanity will no longer be able to influence. You'll probably be surprised, but an ice age on Earth has already begun. Fortunately, we're not in the middle of one, but instead we're in a geological interval of warmer global average temperature called an interglacial period. And when this ends, the real cold will come. So when will this happen? Researchers are trying to find out by studying previous glacial epochs. An analysis of ice samples drilled from the permafrost of Greenland and Antarctica helps to reveal information about the last 800,000 years. Sediment at the bottom of the oceans allows us to look even further, tens of millions of years back into the Earth's past. And the incredible secrets of climate change hundreds of millions of years ago have been revealed by studying the sediment and rocks. Scientists have found that the first Huronian ice age began about 2.4 billion years ago. At the time, the planet received about 15% less sunlight than it does today. In addition, primitive algae emitted oxygen, which displaced methane, a powerful greenhouse gas in the atmosphere. Then, the Earth froze for nearly 300 million years. But at the equator, there were still areas without permafrost. The next ice age, the Cryogenian, wasn't so mild. This era marked the most severe cold in the history of our planet. It began about 720 million years ago. Even at the equator, temperatures rarely rose above negative -20 degrees Celsius. Negative -50 degrees Celsius and below became the new norm for the rest of the world. Scientists believe that even the world's seas were frozen to the very bottom. At the poles, dry ice or solid carbon dioxide appeared on top of water ice. From space, the Earth probably looked like a huge snowball. Check out this NASA image taken by the Cassini spacecraft. This is what Saturn's moon, Enceladus, looks like. Its snow-white surface reflects 99% of the sun's light, and scientists think the Earth was just about the same during the Cryogenian period. Only bacteria and algae near a few hot springs survived this ice age. The cold returned again during the Paleozoic era. Called the Andean-Saharan, the ice age began about 450 million years ago and lingered for 30 million years. But it was nothing compared to the Cryogenian. 3-kilometer glaciers occasionally rolled up to subtropical latitudes, but in general, the temperature was only slightly colder than today. However, everything ended in disaster called the Great Dying, or the Permian extinction, the largest mass extinction in the history of the Earth. According to one hypothesis, the thawing of the Earth at the end of this ice age led to the explosion of a so-called methane hydrate bomb. When methane, frozen in the ground, warmed, it hit the atmosphere like a huge fountain, displacing a significant part of the oxygen from the atmosphere. This resulted in unfavorable conditions for life. 70% of terrestrial and 96% of marine life forms went extinct. Scientists are still looking for what causes global cooling. They discovered that a decrease in the activity of solar flares played a huge part in this. As the planet received less heat and light from its star, the Earth's temperature dropped. To test this theory, American physicist Robert Ehrlich created a computer model of solar plasma behavior. It turned out that its fluctuations coincide with the periodicity of glaciation on Earth. The light of the sun is sometimes obscured from us by galactic gas and dust clouds. Our climate is also affected by changes in the Earth's orbit and its axial tilt. This is shown in the astronomical model of ice ages proposed by the Serbian scientist Milutin Milankovic. It calculates fluctuations in the inclination of the Earth's axis under the influence of the Moon's gravity and the other planets of the solar system. Similar events occur every 26,000 and 41,000 years. In addition, changes in the Earth's orbit have a cycle of 93,000 years. Our planet revolves around the Sun in an ellipse, first approaching our star, then moving away from it. The model calculates that the Earth receives 5 to 10% less heat at the maximum distance from the Sun, as well as during the largest axial tilt, combined with minimal solar activity. When this happens, an area of glaciers increases, and, like all white surfaces, reflects the Sun's rays back into space. This makes our planet even colder, and glaciers start growing in size again. The process continues for millions of years. The Earth is also periodically cooled by volcanic eruptions. Their emissions pollute the atmosphere and trap sunlight. The world ocean absorbs carbon dioxide that warms the atmosphere. Meanwhile, continental plate shifts from mountains and steep mountain ranges can draw carbon dioxide out of the atmosphere. As erosion exposes new rock, it leads to a chemical reaction between minerals on hill slopes and CO2 in the atmosphere, weathering the rock and using carbon dioxide to produce carbonate minerals. According to scientists, a combination of all these factors caused the last ice age. It started about 35 million years ago in the current Cenozoic era. The late Cenozoic ice age is characterized by a frequent alternation of incredibly cold glacial and rather mild interglacial epochs. The Earth has been in this interglacial period called the Holocene epoch for 11,700 years, but the weather during this period can also change. Warm millennia are replaced by cold ones. The last epoch of strong glaciation began about 110,000 years ago and ended 9,700 to 9,600 years ago. After that came the Thaw, which replaced the Little Ice Age that lasted between the 14th and 19th century. In terms of average annual temperatures, it was the coldest time in 2,000 years. Researchers associate the Little Ice Age with the slowing down of the Gulf Stream around the year 1300 AD. Due to severe winters with abnormal frosts in Europe, gardens froze, and cold spring rains destroyed vegetables. By 1350 AD, the Great Famine broke out and lasted for 2 decades. By the end of the 19th century, a thaw arrived again, which has lasted to this day. But eras of strong glaciation usually return every 10,000 years, so we're running out of time. And some scientists predict an intense cold in the near future. So how is this possible when temperatures on Earth are only rising, glaciers are constantly melting, and mankind is actively fighting global warming? We've emitted an incredible amount of greenhouse gases into the atmosphere. So far, this is holding back the advance of glaciers. And yet, according to many scientists, nature will take over. But this may not happen for another 100 or even 1,000 years. However, some scientists think that global warming is actually bringing global cooling one step closer. One model of climate change showed maximum warming of the Arctic Ocean. Freed from ice, water evaporates and falls in the form of snow into the subpolar regions. New glaciers are forming. Scientists believe that in the end, the warm Gulf Stream will not be able to break through their barrier from the Atlantic to the polar seas. Then, the ice sheets will begin to grow rapidly. Whenever this new ice age comes, it'll undoubtedly change the Earth, like what happened during the previous glaciation over 10,000 years ago, when glaciers redrew the landscape of our planet. They compressed many mountains and hills with their weight and destroyed vast areas of soil. Ice sucked water out of the oceans, lowering sea levels. Many rivers transformed into huge valleys and lakes within continents. Land bridges appeared between continents. Canada, Scandinavia, the British Isles, most of northeastern Europe, and Russia were under ice sheets several kilometers thick. If such conditions happen in the next ice age, humans will have a rough time. According to some hypotheses, the temperature at the equator would drop by about 10 degrees Celsius, and in the north and south, down to minus 50 degrees Celsius. In vast areas, the cold would destroy crops and lead to a massive famine. A similar thing happened after the eruption of the Toba supervolcano 74,000 years ago. According to researchers, only 2,500 of our ancestors managed to survive the long volcanic winter. The entire global geopolitical order would also be turned upside down. The borders of most countries would change due to lower sea levels. According to scientists, the ocean level would descend by 150 meters. Malaysia and most of the Indonesian islands would be united into a single landmass. Sri Lanka would once again be connected to India by a surface land bridge, and Ethiopia would merge with Yemen. Water bodies would also change dramatically. Perhaps the Mediterranean Sea would be cut off from the global ocean. Not a single port in the world would be able to accept ships because the ocean waters would roll away from those ports. But what would happen to North America and Europe? Imagine if you lived in Florida and California, where the sun shines all the time, and walking out one morning and seeing the landscape of Alaska. Such climatic conditions would even happen in the south of the United States. Almost all grain crops wouldn't survive there, and food supplies would quickly run out. Those lucky enough to find food would perish from the cold because power stations couldn't survive long in such cold and would shut down. Buildings would fall into disrepair and eventually collapse. Huge crowds of people would move south. Australia, New Guinea, Sub-Saharan Africa, and Southeast Asia would continue to have a warm climate suitable for agriculture. There, new islands suitable for life would form within the ocean, and India and Brazil would probably have the status of world superpowers. The temperature climate and the lowering of the ocean levels would give these countries a huge amount of new fertile land. But would they be able to feed billions of refugees? Some experts believe that they wouldn't. Battles over food would begin with residents of countries with a favorable climate. Currently, the situation isn't that scary because over the last centuries, the development of our civilization has literally skyrocketed. If we have mastered space and visited the moon, then why couldn't we cope with the cold? There are already a lot of interesting ideas about how to survive the upcoming ice age. One idea is to add greenhouse gases to the atmosphere to warm up the planet. And chlorofluorocarbons might just be what we need. This mixture is much more efficient than CO2. Systems like fusion energy could also help to keep the Earth warm. They are designed for Arctic conditions and work based on nuclear fusion reactions. Glaciers could also be utilized to generate electricity. A mile-high wall of ice would inevitably begin to melt on hot days, and water falling from a height of 1,500 meters or more can provide tons of energy. Giant hydroelectric power plants on rails would likely run parallel to a mega glacier, with pipes mounted to its top. Turbines would extract energy from the falling water and then distribute it to eco-farms at the base of a glacier. With the help of genetic modification, unique varieties of crops that are resistant to severe cold could be developed. Farmers would have the opportunity to have good harvests. Then it would be easier for people to adapt to life in regions covered with ice. In the end, the Inuit people did it without any benefits of modern civilization. Although many would still move to a warmer climate, the use of intensive technologies in agriculture would make it possible to feed as many people as necessary. However, after all, we may not need all this. A mild ice age is another possibility, or the next ice age could take some other completely new form. Nature can turn a specific region into a giant desert. Scientists say that now a huge amount of greenhouse gases pollute the atmosphere with particles of various substances. These gases don't allow the sun's rays to reach the planet, but instead warm up the atmosphere. When a lot of these substances accumulate, the Earth could become a huge baked Alaska dessert. Cold and icy on the inside, but with a warm outer layer consisting of the atmosphere. Scientists have yet to find out which scenario of the next ice age is most likely. But whatever the case, the entire history of the Earth is a series of cold and warm epochs. Judging by the previous cycles, winter is close, and it depends on our preparation whether humanity can survive an upcoming catastrophe. The Earth's moon is a bit more than 1/4 the size of the Earth. That's much larger than any other planet-to-moon ratio. The Earth's gravity is strong and keeps us and everything on it from floating off into space. But the moon also has a gravitational pull, although it's much weaker and we don't really notice it. But if you want to see what effect the moon has on the Earth, then look no further than the liquid water of the oceans and seas. All large bodies of water on the planet are pulled towards the moon's gravity, and this causes high tides or low tides. When the moon is over the ocean, water is pulled toward it, creating a tidal bulge. When the moon is full, high tides are significantly higher, and low tides are lower than normal. Now, this is all just regular and normal stuff that the moon's been doing for ages. But the moon does something else every 18.6 years, and we've known about it since it was first discovered in 1728. It starts a cycle of wobbling. Now, this moon wobble is nothing but a regular swaying in the moon's orbit. One half of the moon's wobble cycle causes tides to be lower on Earth, but the second part of this phase, which the moon is currently headed in, causes higher tides than normal. So if this is a natural thing, what's the problem? The big issue is that climate change is causing the oceans to rise. And combined with the moon's wobble, NASA is now issuing a dire warning that by the year 2030, the Earth could start to see massive flooding in coastal cities all around the globe. And we've already seen devastating floods in 2021 that are unbelievable. And we'll get to those in a moment. Currently, the moon wobble will temporarily suppress flooding from rising sea levels. But as the moon sways back in the mid-2030s, we could see some of the worst flooding in coastal cities across the planet, and this would last 10 long years. In 2014, the global sea level was almost 3 inches above the 1993 average. And if you asked any climate scientists at that time how fast the levels of the oceans are rising, many would say 1/8 of an inch per year. But things have been accelerating, and big time. Faster melting of Greenland's ice has pushed the rate to 4.8 millimeters per year, according to an ocean scientist at NASA's Jet Propulsion Laboratory and head of the agency's sea level change. But there's a lot more happening than sea levels rising. The tides do more than make huge waves in the ocean and on beaches. They also impact the movement of currents, and that directly impacts the weather by the amount of warming or cooling water moving through a specific area. Weather events like El Niño, a climate cycle in the Pacific Ocean, starts when warm water in the western tropical Pacific shifts eastward along the equator towards South America's coast. Water temperature combined with strong winds and direction create weather events like El Niño. The moon's tidal forces also affect the amount of rainfall on Earth. Scientists discovered that when the moon is high in the sky, it also creates bulges in the planet's atmosphere, and that leads to changes in the amount of rain that falls below. These atmospheric bulges create pressure on the side of the planet the moon is directly above. But here's something surprising that you didn't know. The moon also affects polar temperatures. Satellite measurements of the atmosphere over the poles show a rise in temperature of 0.56 degrees Celsius when the moon is full. Although they're slight, these temperatures can affect weather all around the world. Now, consider that in the USA, almost 40% of the population lives in high population density coastal areas. And globally, 8 of the world's 10 largest cities are near a coast. According to NASA, these coastal cities need to take action now and brace for coming floods. Climate scientists are already stunned by the massive amount of flooding around the planet in 2021, especially Europe. And from the looks of things, we're not prepared at all. Several European countries have been hit by floods in 2021. In March, extreme rainfall on the east coast of Australia led to widespread flooding in New South Wales and affected regions from the north coast to Sydney, which experienced the worst flooding in 60 years. Many parts of the coast were declared a natural disaster zone, and over 18,000 people were forced to evacuate. The flooding caused over $1 billion of damage. But this was just one place on Earth that saw unbelievable flooding thanks to climate change. Regions in Central Europe have seen the worst flooding in decades and has left the region in complete shock. Entire corridors of destruction have been carved through the landscape of Western Germany and Eastern Belgium. The flash floods came unexpectedly, and on July 14th, 2021, a whopping 153.5 milliliters of rain fell near Cologne, twice the amount the average rainfall for the entire month of July. And Eastern Belgium, an unbelievable 271.5 milliliters of rain fell in just 48 hours, making a national record for 2-day rainfall. In the Belgium town of Dinant, waters were so fast and heavy that cars were picked up and washed down roads. More than 200 people lost their lives, with just as many missing. This was Europe's 10th deadliest flood in the past 100 years. And here's an interesting thing: these floods were predicted 9 days prior, with almost pinpoint accuracy, but residents were not evacuated or warned. But this isn't the only place to be hit by heavy floods. China's been devastated by severe flooding from heavier rains than normal. In fact, this was China's heaviest rainfall in 1,000 years. Horrifying visuals of cars overturned and floating down roads, and people trapped in subways waiting for rescuers, showed us a grim picture of what climate change is doing to our planet. 20 centimeters of rain fell in the city of Zhengzhou in central China's Henan province. But that's not all. Heavy rains and mudslides recently hit Turkey, forcing thousands of people to leave their homes. Devastating scenes online showed stranded villagers being picked up off rooftops by helicopter, bridges collapsing under the force of rushing water, and cars floating down streets as residents were being rescued. Turkey has seen soaring temperatures of over 50 degrees Celsius. Now, here's the interesting thing. Even if the world follows a low greenhouse gas emission plan, global sea levels will still rise by at least 30 centimeters above 2000 levels by the year 2100. Although there is some uncertainty about the full volume of glaciers and ice caps on Earth, if we keep going in the same direction without some serious changes, and if all the land ice was to melt, the global sea levels would rise approximately 70 meters and would flood every coastal city on the planet and many more cities inland. To give you an idea of how catastrophic that would be, that much water would touch the left elbow on the Statue of Liberty in New York Harbor. However, scientists say the Antarctic ice cap, where most of the ice on the planet exists, has survived much warmer times. The Earth is almost as warm now as it was 125,000 years ago, and sea levels were 4 to 6 meters higher. But global warming and the changing climate doesn't only cause water disasters from melting ice. The United States and Canada have been hit by severe heat waves that have resulted in heavy loss of life. For example, in the village of Lytton in Canada's British Columbia, temperatures soared to a high of 49.6 Celsius, and to make matters worse, that city was later destroyed by a wildfire. And in Portland, Oregon, USA, temperatures were as high as 46 degrees Celsius. Satellites are now tracking record-breaking and devastating wildfires all over the planet. Wildfires in Turkey are the worst in over a decade, and Russian fires in Siberia are worrying scientists the most. These devastating fires have emitted a record 505 megatons of carbon dioxide. And fires in the USA, especially the Dixie Fire in California, are burning out of control. What we're seeing now is unprecedented. Rocketing temperatures will create flooding, heat waves, wildfires, and global drought that will have a severe impact on millions of people. But the Earth has been heating and cooling for billions of years since its beginning. Humans will have to deal with Mother Nature and prepare themselves. So the next time it feels a little more humid than normal, or you hear about El Nino in the news, look up at the sky and think about the moon. Thanks for watching.